Hello and welcome to the Nerd Herd, where today we're going to be doing a little bit of a deep analysis on AMD's 2019 CES Keynote. I'm going to be skipping to the stuff that we actually care about. I'm not going to be doing an analysis on Epic or Ryzen Chromebooks or anything like that. So without further ado, let's get right into it.
I'm not sure I can hear you.
So we're going to be going in the So we're going to be going in the order that they actually present these, and the first thing that is actually relevant that they present, and I'm going to go ahead and apologize now. They streamed it in 720p, that's why it looks so terrible. But we're going to be starting with the new upcoming Radeon 7 GPUs. I'm going to say real quickly, I kind of laughed whenever I saw the 3 fans on this reference card, because one of 2 things is happening with 3 fans on that card. Either really AMD's entire business model is one-upping, so either they're trying to just one-up NVIDIA by adding 1 more fan, or the less funny and kind of less fun part. It might be because those cards run so hot that they actually need 3 fans on a reference model, which would not be good, as you could probably think. Okay, going to continue now.
Today, I'm really happy to show you for the very first time our new high-end GPU for gamers and creators, AMD Radeon 7. Radeon 7 is the 2nd generation Vega graphics core. It is the world's first 7nm gaming GPU. And when you look at what it delivers, we really deliver leadership performance in content creation, thank you, and compute workloads. And so when you power enthusiast level gaming, you need it in all kinds of ways. So where does all that performance come from? Radeon 7 has 60 compute units running at up to...
Okay, so you see a few specs on this. First one is 60 compute units. That really doesn't mean much until we actually see the performance, because that'll tell us how powerful each compute unit is, but for now that doesn't really mean much to us. But the 16 gigabytes of HBM2, that is later specified, but HBM2 memory, this is one thing that's just kind of been a theme with AMD all of their GPUs have an absolutely overkill amount of memory. And that's why they were so good for mining. The 480 was the most sought after card for mining whenever mining was still really a thing. But they have 16 gigabytes of high bandwidth memory, HBM2, at 1 terabyte per second. That's insane. And this is just kind of regular succession of next generation GPUs, so not that interesting. But I want to say real quickly, this is expensive. This is probably a good chunk, probably not most, but a good chunk of the cost of the card. Continuing right along.
To 1.8 gigahertz. Radeon 7 uses advanced 7-nanometer process technology. As I said, this is the world's first 7-nanometer gaming GPU. And what we get for that is 25% more performance at the same power. And lastly, Radeon 7 has massive memory. 16 gigabytes of high bandwidth memory with industry-leading terabyte per second of memory bandwidth. So if you think about all of that memory and all of that compute, you can imagine how good this GPU is for content creation. If you take a look at some of the most important benchmarks in creative workloads, we see up.
Okay, so we see some different video rendering softwares. Blender, DaVinci Resolve 15, and Adobe Premiere are all video editing and rendering softwares, and OpenCL is just, whatever. Don't really need to worry about that. But what's interesting about this is the fact that they're going all crazy about how it's for gaming and everything, yet they're going with high memory for content creation, and, well, this is what they show first. It's not gaming that they show first, it's content creation, which doesn't really make sense to me, but they're their own company, whatever. Continuing right along.
To 30% improvement in things like Blender and Adobe Premiere. You can imagine 30% does a lot. We see up to 62% more performance in GPU compute workloads based on OpenCL. And when you think about all of these performance gains, they are really, really good for creators, and we love that. But we know that you guys want to know, how does Radeon 7 perform in gaming? We really built Radeon 7 for gamers, and these are the cream of the crop. The folks that want high frame rates when playing at the highest quality visual settings at max resolutions. And we have some really large improvements from first generation Vega. What you see is across Vulkan, DX12, and some of the popular esports titles, you see significant improvements when running at 4K and max settings.
Okay, so here we have some performance related numbers. This is of course against their previous generation. At least this whose leg is in the way. But this is the RX Vega 64 against their Radeon 7. And I want to say real quickly, the 7 is because it's 7 nanometers. But yeah, so we see 35% increase in Battlefield 5 and Fortnite for whatever reason, and Strange Brigade, which, I don't know, their numbers, it's a good increase, but nothing too exciting. Continuing right along.
And the thing about Radeon 7 is we also use some of our new Vega features. Things like async compute, rapid pack math, shader intrinsics. These are all being used by game developers to create even better and more immersive gaming experiences. But that may be enough of me talking about the card. You may actually want to see Radeon 7 in action. So I think my friend Chris is here, Chris, let's show Radeon 7 running a really, really cool new title. It's the upcoming Devil May Cry 5 running at 4K.
Okay, so they just have some guy that we don't know, not really, running an upcoming game that's most likely very AMD optimized. Take these numbers with like a massive tablespoon of salt, because both it's AMD optimized most likely, and we don't have numbers, we don't have actual solid numbers for cards from both companies, so massive grain of salt with these.
So this is the first time that Devil May Cry 5 is being shown, running on Radeon 7. And it's the latest version of the successful Devil May Cry action-adventure feature series from Capcom. AMD has actually worked very closely with the development team to optimize the game engine to create the photorealistic characters and some of the environments that you see here. And if you take a look at the performance, we have the frame rates up there. You can see the game is running super, super fast in 4K ultra settings, way above 60 frames per second. So there you see it. I want to give a really, really big thanks to our partners at Capcom for letting us show DMC5 before it launches. This title launches March 8th, and we're really excited to be working with Capcom on it. So thank you very much, Chris. We really believe at the high-end enthusiast market, you need great hardware. And gamers who want to run AAA titles in 4K at max settings will be really happy with Radeon 7 and how it performs compared to the competition. Radeon 7 has better performance in some of the latest Vulkan games, like Strange Brigade.
Okay, so we see some performance numbers against NVIDIA's RTX 2080 non-TI. So this is not their flagship, and it's barely outperforming them. Now you may see Strange Brigade and be like, wow, that's a pretty good increase. Strange Brigade is really AMD optimized. That's why there's a 14 FPS increase here. And the rest, well, all three of these are probably their like best case scenarios. So if their best case scenarios are marginally beating the RTX 2080, except for in one game where it's optimized for AMD cards, then once again, take these numbers with a grain of salt. Keep being great. Also, but it is kind of interesting that AMD is beating NVIDIA at Battlefield 5, but also think this is at the exact same price point. It's not like usual where AMD is doing a similarly performing card for a couple $100 less almost. This is marginally better on 2 games and a wide increase on an optimized game, and with less features, because this card right here does not have ray tracing. This is just a regular old powerful $700 card. Not very impressive, if you ask me.
And it's very competitive at both DX11 and DX12 games. And I know for some of the press here in the audience, you guys are waiting to get Radeon 7. you will get them and be able to do some really cool reviews. Now, in addition to Capcom, we partner closely with many developers. And it's really that close partnership that allows us to take advantage of the features of our Radeon GPUs. So to discuss a bit more about our partnership with game developers, let me invite David Pullfeld to the stage. He's head of Ubisoft's massive entertainment studio. David?
Okay. Next up, we have the real meat and potatoes of this little video, AMD Ryzen.
Are you guys excited about Ryzen? I love you guys, by the way. I love you guys. Look, our mission with Ryzen has always been clear, okay? Our job is to push the boundaries of what can be done by a desktop processor. The third gen Ryzen processor is the next big thing in that mission. Third gen Ryzen is also powered by the Zen 2 core, also has 7nm technology, and as a desktop processor, it will absolutely set the bar on performance, technology, and power efficiency. And to show you a little bit, I'm going to give you today the first ever public preview. Note, it's a preview of what next-gen Ryzen can do. So let's take a look. Let's begin with PC gaming. My friend James, are you ready? Okay, James, let's show the audience what we got here.
Okay, so at this point in the keynote, they are doing a little bit of a benchmark, quotation marks, on, I believe, Forza Horizon 4, but this really, like most of these things, take it with a grain of salt, because if you look up in the upper right hand corner, it says GPU 97%. Anywhere between 95 and 100% means the GPU is being bottlenecked. So, and they said that they're using the Radeon 7 for this specific test. So that means whatever processor that they have, it's not getting utilized, so it's not really a benchmark. Also, they say this is like the top of the line best gaming stuff ever. NVIDIA RTX Titans exist. They are much better than 2080s, which these Radeon 7s are being compared to, and you can put them in NVLink. So it's not the best. How it stands, you'll see the performance in a second. It might be better, might be the best processor-wise, but not at all in the way of GPU. Continuing on.
So what you're seeing is an early version of our third gen Ryzen desktop processor. By the way, it's also running with Radeon 7 GPU. It's running the performance-intensive Forza 4 gaming from Microsoft Studios. And we like this game because it really stresses the computing power. And as you can see, we have the frame rates up there. The game is running consistently at more than 100 frames per second at 1080p with maximum settings. This system that James is running is the most advanced PC gaming hardware in the world. together in one system. 3rd Gen Ryzen, Radeon 7. What do you think? Thank you very much, James. Good job. You didn't crash. Thank you. He was worried, by the way. I was worried too. But look, I know you guys well. I know the enthusiast community. And you're asking yourself, how does Ryzen really perform compared to the competition? So let's take one more look, just one more look. Let me make sure I have my guys. Okay, you guys are there. Sit tight. Louis and Amit are from our engineering team, and they've been with Ryzen all along. What we're going to show you today is now 3rd Gen Ryzen with a head-to-head comparison against the top-of-the-line Core i9 9900K running the industry standard Cinebench benchmark. So note, let me tell you what we're running. We're running 8-core, 16-thread Ryzen, not final frequency, early sample, and we're running stock frequencies of the Intel part. So,
okay, this might kind of be a weird pause, but this is going to be a little bit of a person analysis. You'll see by how close the numbers are in just a second, but I think she's a little bit stressed to see what the outcome is. For those of you who have done benchmarks before, you know they're never exactly identical to the last one. There's always a range that they fit into. So you'll see the numbers and you'll see what I'm talking about.
Louis and Amit, are you ready? Okay, let's start the demo, please. So Cinebench is going to run for a little while. What you're also seeing, just so you know, are the powers. These are the system powers that you see from each. And as I said, the image on the left is the competing processor, the image on the right.
Okay, so it's very hard to see because it's both small and in 720p, but the 9900K, which is on the left, got 2040 CB, while the 8-core 16-thread Ryzen, the 3rd Gen Ryzen part on the right got 2057. It beat it by 17 points. That's why I was thinking that she might be a little bit stressed, because that's pretty much margin of error. And, well, makes sense that it would be a little bit more impressive if it beats it rather than it gets beat. Also, you see the system power usage here and here. This is pretty massive. This is about, I think she says, like a 30% decrease in power usage between the 9900K and the 8-core 16-thread part from Ryzen. That's pretty massive.
Is Ryzen. And what you can see, let's take a look at the Cinebench scores. Ryzen looks like 2057. Our competitor's running at 2040. So that sounds like a win. Does it sound like a win? The other thing that's really important is the system power. So you can see that the system power of 3rd Gen Ryzen is running actually about 30% lower than of the competing system. So now you really see the power of 7-nanometer technology and what being aggressive with technology does. So thank you, Louis and Amit. Great job. As you can tell, I really love building chips, okay? I really love building chips. And some of you may actually wonder what third generation Ryzen actually looks like. So, take a look.
Okay, so she shows off a little bit of the die. Now, why this is important. From what we know, this, the smaller one, is the actual CPU, while this is the I/O. There have been some leaks, as I'll show you up here, about specs and dies. So, why this is important. This might just be the Ryzen 5 that she's showing us. Disregard this because that's only for the G version here. But for these two right here, that chip that she just benchmarked is most likely one of these two. Now, what that means? That means that at least as far as cores and threads go, most of this is probably true. Because now that Intel has released a consumer 9900K i9 whatever, AMD does this a lot. It's not necessarily a bad thing, because when they do this, when they say, hey, Intel's doing an i9, we should do a Ryzen 9, it never turns out bad. It's just a straight up rip-off all the time. So if there's 8 cores here, and as you saw, this is the part that she just benchmarked, and there's 8 cores there, one could assume with this big gap right here that you might be able to fit another, if I didn't scroll too far down, 8 cores for a total of 16 cores and 32 threads, which would make sense. Also leaves space for their Navi APUs here and here for Ryzen 3 and Ryzen 5. This would make sense because this is like way too insanely high-end for Ryzen 3. With how they're progressing, it kind of makes sense for Ryzen 5, so that makes it to where this makes sense. But most of this is just speculation. From what we know, only this is true. Not even this. This isn't even true. Just this. Just 8 cores and 16 threads. We don't know if it's a Ryzen 5. We don't know frequency because she said that's not necessarily valid. And we don't know price. Now, it's interesting what this is going to do to thermals, because this core right here is 7 nanometers, while this is only 14 nanometers. This is kind of a cost-saving measure. So, making this 14 nanometers, the I/O chip, makes it much cheaper to make, but doesn't necessarily decrease performance in any meaningful way. Also, splitting up the die can also be seen as a cost-saving measure, because previously, whenever it was all one die all together, you had to physically destroy cores and deactivate them, or deactivate SMDs to get lower end processors like Ryzen 3 and Ryzen 5. And only Ryzen 7 had all of their SMDs active, but they were still having to make a full Ryzen 7 for each processor. And then if the silicon wasn't quality enough, then they just deactivated a few SMDs and made it a lower end part. This way, they make one little die for one little 6-core die for Ryzen 3, one little 8-core die for Ryzen 5, two Ryzen 3 dies for Ryzen 7, and just put them on the same chip and never have to deactivate SMDs. And for Ryzen 9, from what I can think of, like, this one doesn't even have a leaked die shot like this one. Two Ryzen 5 cores on the same chip. It's going to be very interesting to see what this does to thermals, because what Intel is planning to do with some of their chips is to stack them. These are both kind of adding a little bit of an interesting effect to thermals, although I think this might actually be beneficial. This might be hurtful because now they're covering their actually heat producing and cooling needing parts with DRAM, which will, I don't know. I don't know how this is going to work out, but this is straight from Intel, so, whatever. Yeah, so, thank you for watching. Subscribe, unsubscribe, like, dislike, comment, I don't know, do whatever. You're your own man or woman, and good